The Layer 2 configuration lab continues. We've got the base configuration laid on switch 1, 2, and 3. Good. Now let's continue on in our lab guide. So bring that back into the screen. Everything fits. Good. So here's the base configuration we did in part 1. Don't even need to review all that because, well, we just finished it. So now we can move on to part 2, which is the necessary VLANs. So once again, this is pulling from our guide that we created, our design guide that we created for ourselves, listing all the VLANs that we have. Now notice in the instructions it says configure all the necessary VLANs on the switches. If a VLAN is not necessary, it should not be configured. So notice right here we've got switch 1, switch 2, switch 3, and what VLANs are on them. Now, there's a few trains of thought, and it depends on where you come from. You remember, perhaps, about VTP. Cisco's VLAN trunking protocol allows you to create all the VLANs on one switch, and they replicate to all of the others, meaning I only have to create them one time, and then everybody else just magically gets them. Turned out to be a bad idea. First off, because of the risk, because if somebody gets on a switch and misconfigures it, it could delete all the VLANs across your enterprise. Not good. Likewise, Cisco then determined performance-wise, it's just not good to have all the VLANs on all the switches and all the VLANs on all the trunks, because, for instance, if you're only using 2 VLANs down here and you've got 50 of them in your organization, then this trunk is getting the traffic for all 50 VLANs, all the broadcasts, all the communication, and it's just getting here and dropping because this doesn't have 48 of the 50 VLANs even assigned on that switch. So Cisco now says, hey, it's just best performance-wise, it's best design-wise, and scare tactic-wise with that VTP, not to have all of the VLANs on all the switches, and Cisco recommends do not use VTP. So here's what we've got. We've got our core switch, which needs all the VLANs, and then our two IDF, we've got the IDF switch and then just the user switch, which just has the voice VLAN, data VLAN, the public Wi-Fi VLAN, and the management VLAN, because we have to be able to manage those switches remotely. All right, so what I'm going to do is I've got my answer key ready. And I'm calling it an answer key because it contains all of the commands that we're typing in as we go. And it'd be great to include this, so if you are doing this yourself, you can review to see if you followed the right direction. So I'm separating these with little comments. So I've got Objective 1, which was the base config. We just did that. Now we've got Objective 2. Now one quick thing before we move into this is GNS3 has, of course, quirks because, well, you're emulating a Cisco router. Of course, you can't do it perfectly, right? So there is an issue, and this is something you probably saw when I did the last nugget. When I tried to edit the VLAN database, it said, sorry, there's not enough room on flash. Well, it's because GNS3 actually doesn't boot the router from flash. It boots it using some mystery magic it does with its iOS and hypervisors and all that kind of stuff. So there's actually no storage space available on the flash. So I did a quick search, easy enough to do, just say, VLAN database, GNS3, and the first thing I actually found, did you know that if you search for VLAN but you misspell it VLAD, you actually get a little info on Vlad the Impaler, which I read this Wikipedia article. This is Dracula, which was really interesting because I'm Romanian, well, at least half Romanian. My father was born in Transylvania, and so was this guy, who killed tens of thousands of people, and it's really quite sad and morbid. But if you're looking for VLANs, on the other hand, that's where you can type in VLAN database and GNS3, and there's a guy who's written a great little article on how you do this. It says first thing you do, you need to wipe out the existing VLAN config, erase the flash, sure, squeeze the flash, that just completely annihilates it. Then we go into global config mode, and we tell the router, switch router, swouter, to save the VLAN database file into NVRAM, which GNS3 does support and can do that. So let's do that. Actually, I should have tested it, but I haven't tested it yet. I just figured, why test when we can just do it together? Erase flash. So let's start there and let that do its thing. And actually, I'm going to do this on every single one of these swouters. Oh, if I could get that in there. So let's shoot over here and just do an erase flash. Yep. And erase flash. Yep. So that way we get it the same on all of them. And let that go. Good. So we've got the flash erased, and now let's jump into the squeeze. So let's do a squeeze flash. Got that. It might take a while, but maybe not. So get that replicated on all of them. They're still going over here. So we'll do that in just a second. Let's see, where's that website? So now, this is how distractible. It's erasing. I'm like, ooh, I just heard from somebody. Cisco's got a great deal on a little small business switch, so I went to go check out this gigabit switch. And so anyway, so let me close this down and take my ADD pills, and then go down here. I have a theory. I don't think there really is ADD, just a lot of lack of self-discipline focused people like me. So I'm going to go into global config mode, and then we coined it and we said, well, so many people are this way, so let's call it ADD. So I'm sure just like that, I'm getting emails. People are like, no. So anyway, so we've got VTP redirected VLAN.dat. Is now stored there. Wow, that's I've actually honestly, and obviously real world you never have to do that command, so it's kind of cool to see it work. So let's do a show NVRAM, or wait a sec, dir NVRAM. Look at that, VLAN.dat in NVRAM. Who knew you could do that? So let's save our config there. Yeah. All right, so we've got, so let's add that list O commands to our little running list we've got. There we go, got those added. Now let's shoot over to here and let's just, it didn't work. My little paste method didn't take off there. So there we go, VTP file, good, do right, and then squeeze flash. Yes, config T. It's the confirmation. Need to put an extra enter in there because it asked for a confirmation. There we go. So now that'll work. So enter down a little ways. Okay, good. So that's just, again, getting the base GNS3 tweaks set up so that we can go on our way. Now let's get our VLANs created. We've got VLAN 64. So this is, let me do it manually on the first switch, and then we'll just paste it into the upcoming switches. So let's go switch 1. Now this, and again, I'll remind you, this is the old school way of doing this, because now modern ways, you go into global config mode and do VLAN and type in VLAN information in global config mode. This is probably what you saw in the original ICND1, ICND2 series. But in GNS3 you have to use ether switch modules, which go a little old school. So same concept, just different spot. I'm going to go into VLAN database, and we will do VLAN 64. Yes, yes, yes. Name, client, voice. Now you can put spaces in it if you want to. You can actually put in quotes like this, and then go ahead and add a space in the middle. Why don't we do that? So we've got VLAN 64 added. You know what? Before I do all this, I want to make sure it applies. Look at that! It worked. Thank you, genius, who created that NVRAM redirection. Okay, so we've got VLAN 64, VLAN 66. We've got client data there. Oh, nice. So let's go over here, VLAN database, VLAN 66. We'll do client data. Good. So let's do next up in the list. Matter of fact, you've seen this. Let me pause it while I type all these in. Actually, I figured now that we've seen the concepts, why don't I just slam them all in here, and that way we can just copy and paste them into the configuration. So let's see, left off VLANs. Okay, 66. So now I can just go paste, get all those guys in there, exit, good. So now let's do a show VLAN. This is on switch 1. And again, we're in the ether switch world, so I'm going to do show VLAN switch. That's the alternate command. Now again, real switches, you're just going to type in VLAN, show VLAN, and it's good. But this is good. So we've got all of these created. Now, one thing I was thinking, I think in our original design, I did VLAN 10 as Internet DMZ. And actually, I know I did. And when I originally designed this, I thought that would be the little subnet between here and the switch. But then later on, I said, okay, I'm going to change that to a routed interface. Matter of fact, that's part of this lab. So I'll show you that. But I still want this VLAN 10 around because I have some other purposes. A lot of the feedback I've been getting is, we want to see best practices for DMZs and things like that. So yeah, I want to show you that. So let's keep that there. So we've got the VLANs created on switch 1. So let's just see if my little copy paste everything will work here. Let's shoot over to switch 2, exit out, and paste. Look at that. Exit. Wham. Good. Paste. Oh, whoa, 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 Jeremy, what are you doing? What are you doing? Just a second. See, that's what happens when you move too fast. I created all the VLANs on switch 1. Correct. Now on switch 2 and switch 3, I just did the same thing. So now I need to go back. So let's put a little exclamation point here and do switch 1 config. And then let's do switch 2 and switch 3. Let's just do and switch 3 because they're the same. And let's just tweak this out to have just the VLANs that we needed. Okay, good. So now let me go back here again. And let's see. I know I've got switch 3. Oh, I already pasted it, didn't I? Okay, so no VLAN 10, no VLAN 70, no VLAN 68. Correct? That's just that's the differences. 7 VLANs here, 4 VLANs here. That's good. Okay, so VLAN database, no VLAN 10, no VLAN 70, 70, and no VLAN 68. Good. Easy enough. Now, one of the things I'll warn you about, a lot of you, like me, reach for your Control-Z. You don't want to Control-Z out of there. I believe, now let me just double verify, some versions of the iOS, okay, it just won't let you. Some versions of the iOS, when you hit Control-Z, it actually would abort the changes to the database. So it would undo everything you just did. So it looks like at least it bans you from doing it here. Good. So let's go back to the lab. So we've got, good. So the second objective taken out. Good enough. Now let's move on to Ether channel connections. Now, Ether channel was one that I went above and beyond the typical CCNA. Now, it's not in there now. I think in the typical CCNA, it's mentioned. Like, you might hear of it. I may have even mentioned it in the original series I did. But you definitely don't get in the configuration of it. But the funny thing is it's so easy to configure Ether channel that it's just the concept that you have to get. So let me hit the concept real quick. Ether channel, and I mentioned this briefly before, allows you to bundle multiple links into one logical connection. So if you don't have Ether channels, Spanning Tree is going to step onto the scene and say, nope, sorry, that's redundant. It's looped. We're going to block one of them, which is good because it stops your broadcast storm, but bad because you want that bandwidth. First thing to know is you can only Ether channel between the same device. So for instance, I can't put all these into one giant 4-channel group because they're not all going to the same device. It has to be the same device. They have to be the same speed, same characteristics. Like this can't be an access port and this one be a trunk port or something. They have to be identical in the configuration. But the big thing I want you to know, let's say these are 1 gigabit links. When you Ether channel them together, your total throughput, and I got to be careful how I say this, hang on. Your total throughput on any one transfer will never exceed 1 gigabits per second. And let me explain that. What I'm trying to say is it doesn't literally splice together these cables and then give you a 2 gigabyte connection. Meaning, if I had a file on this server and a file on this PC and it was 50 gigs, I wouldn't drag and drop and see 2 gigabit throughput. I would only see 1 gigabit. But what it does is load balance. So for instance, maybe the first connection from PC2 to the server uses this link. And then maybe PC3, not pictured here, he goes to the server, he'll use the other link. So you do get to use both of the links, but you'll never exceed the speed of any one link in there. So that's Ether channel in all its glory. It's redundant. It can survive if you lose any one links. You can bundle cables in the way the algorithm works. It's in powers of 2. So you can bundle 2, 4, or at most 8 cables together into an Ether channel bundle. That it's able to use. Now, Ether channel is a Cisco word, which is good. Other vendors call them lag ports a lot of times, link aggregation. Now, when you configure this, there's actually three different ways that you can use. You can use LACP, and you might remember this from the lab, PAGP, or you can just hard code. I'll put HC. LACP and PAGP are negotiation protocol. So if one side's like, hey, I want to be an ether channel, the other one's like, no, I don't, then the ether channel won't form. So it's kind of good because if you hard code one side and then the other side is not set, you lose the link. So usually anytime I'm like, it's kind of auto-ish, and I still like hard coding, but that's really all these do is negotiate between the two sides. Is one better than the other? No. They're not. They're literally almost the same protocol. It's just Cisco was first to the game with this ether channel concept, so they came out with their proprietary PAGP, and then the industry caught up and they created an industry standard LACP. Now this is the more popular protocol nowadays just because every vendor supports it, and you can ether channel. I mean, you can even start doing ether channel or lag ports to individual servers, like if that's a virtualized server or something, you could lag all those together into one giant link, and VMware would support that, Hyper-V would support that with LACP. But PAGP, there's no disadvantage to using it other than you only can use Cisco devices. If you would consider that a disadvantage, I don't know why. So what I said in the lab guide, or I should take me out of it, what the lab guide dictated is the ether channel should be hard coded as on. And you might say, well, I wanted to kind of use negotiation. Well, with GNS3 you can't, or I should say with ether switch modules you can't. So let me show you how easy this is to do. I'm going to go into switch 1. So let's make sure we get our ports right? So we've got switch 1, and let me just get my chicken scratch out of here because I'm going to go into GNS3, and where's it at? View, show interface label. Whoa, okay, so that's why it's normally hidden. So we've got our interface labels right there, and I'm just seeing they're all on top of each other. So, okay, it looks like the ones going to the bottom links are FA 10 and 11, and then the one going to switch 3 is F12 and 13. I hope I said those okay. So we'll keep those on there, I guess, while we're doing this. Here's how you do it. Go into switch 1. I'm going to go into, I'll do interface range, so I can do them both at the same time. FA 1/0 through 1. Some iOS versions, you got to get the spacing exactly right on there. So, and by the way, that's such a pain because that doesn't show up in the context-sensitive help. It's really hard to figure out if you don't know that. So, you got the spacing there. So FA01, so that's going to be going down here. So let's make that. I'm going to do channel group 1. Now, the channel group number, it is just a number. You can see you can have up to 6 ether channels on this device. The channel group is just a number, and you can make it any number you want that's supported in that range as long as it's unique. So, for example, over here, I'd want to have channel group 1 for this, and then channel group 2 for this. It does not have to match the other side. I could use, if I wanted to, channel group 2 for here. I mean, if you're crazy, and channel group 5 for this. It doesn't have to match as long as on the same device we have something to distinguish between the different ether channels that are running on there. So let me get back to the config. There we go. One window will be it. So we'll do channel group 1, and then mode. This is normally where it would give you options like active or passive, and that will dictate whether you're enabling LACP and PAGP. There's actually no, well, I take that back. There is a command where you can choose LACP or PAGP, but it's rarely used because in the modes it will give you the option. You'll see it in the list, but on here it's just on. We don't have negotiation here. So okay, that was huge. Freeze! Look at that. What it just did was create this port channel 1 interface. Now, I can't emphasize what I'm about to say enough. Maybe I can. It is, once you do this, you will create a virtual interface. Let me do a show run on this guy. Okay, so you see right here we've got FA 10 and 11. They've been added to channel group 1. And look at this. This new interface appeared that is port channel 1. And that interface is now where all of your configuration will go. You don't want to get under here and do your config. Don't want to do that because otherwise the iOS will destroy you because it will say, "Oh, sorry, the config on this no longer matches the config on this. I'm tearing down that guy. I'm pulling him out of the port channel. He's no longer a valid member," and it'll destroy it because now everything goes under this newly created. Let's call it a logical interface, right? So I'm going to go into global config mode. Give you an example of this. Port channel 1, let's do speed 100. Let's hard code our, oh, wait a sec, we can't do that here. Can we do duplex? Sure, okay. So let's do duplex full and type that in. Control Z back out, let's do a show run. And you can see now we've got duplex full typed in under the port channel, but look what happened. The iOS is wise, and it said, that applies to the individual interfaces. Now, some stuff will do that. Some stuff will just stay under the port channel. It's all in how the iOS handles that config and applies it. So we've got those typed in and hard-coded underneath there. So that gives you an idea of what that port channel interface is. Now, let's go in and do interface range, FA1/2 through 3, right? Because we've got 2 and 3 now going to switch 2, or switch 3. So I'm going to do channel group 2 mode on, and wham, we've now created channel group 2. Notice it created another virtual interface, and now it's starting to make more sense, right? Because I can't put all these in one channel group because the config may be different between switch 1 and switch 3 and switch 1 and switch 2. So that is the configuration of Ether channel. Let me add that to our answer key. Okay, I got it. Well, and I actually went a little above and beyond. You can see I added just, objective 3. This is our Ether channel. I wonder if I should put that'd be good. A brief description next to each one of those objectives so we can remember what they're for. So we've got switch 1. I've got those commands typed in. Now switch 2, I haven't actually pasted these in yet. Switch 2 and switch 3, I've got the interface range command just for one channel group. And remember, each one of those guys, if we go back to our diagram here, each one of those guys has FA10 and 11 connected back over. So what I'm going to do is let's hide those guys. I'm going to go into each one of those switches. And actually, before I forget, I'm just because I'm going to take out that duplex full on that. And I know some of you are like, wait, that's going to be auto negotiation. Well, yeah, but it'll work, I think, on GNS3. Let's just keep it simple until everything is up and running. So we're going to go over to switch 2, and let's paste in the command to create channel group 1. Add those guys in there. They joined. Good. And then let's go here. Exit out of that. And create channel group 1 as well. So now we should have functional channel groups back over. We can do a show ether channel. Let's just do a summary. And you'll be able to see that we've got now port channel 1. And you can see the little key up here. It's a layer 2 port channel. You can actually do layer 3. That's when you get into layer 3 switching and routed interfaces and so on. Oh, oh, that's funny. That is funny. Here I am saying, oh, it'll work, and look at that. We've got duplex mismatch. Okay, Cisco, you got me. My statement stands. Yeah, auto not use it, right? Never use auto negotiation. Let's do that on port channel 2. That to me is just funny that it just happened just right then. That's okay, so let's go in back into here. Let's do, oh, I haven't typed in the command yet. Interface, port channel 1, duplex full. Hard code it. Exit interface, port channel 1, duplex full. There we go. We're hard coded all the way around. This one doesn't allow us to hard code the speed. We probably could if we went under the individual interfaces. So now let's go back and see. Let's go on switch 1 and show ether channel summary. And that's good. We see both of these guys. We've got layer 2 and it is currently in use. It's up, it's working, and I see all of these guys are in the port channel, and that's good. And you don't want to see D's, the little downs, when you're configuring that. So that should tell us that it is working and everything is good to go. Next up, we're going to get into the trunking, but I'm going to do that in the next nugget. I'm famous for just trying to cram so much stuff in, and then it just goes too long. So for now, we've now hit VLANs. We've added all the VLANs. We've got our GNS3 environment configured to support the VLANs and added them to the right switches. We've configured the Ether channel, which appears to be working based on the show output, but we don't have any IP addresses on the devices to test as of yet. So in the next nugget, we'll get the trunking going, and then let's see if we can get some testing going on where we can see if everything's working. For now, I hope this has been informative for you, and I'd like to thank you for viewing.